was good job. Day 190 something. 8 or something. We're almost at day 200, so that's pretty nice. Okay. I think this is gonna be for sliding window. I think this is gonna be my last problem for sliding. I think I did like about a decent amount. I'm gonna do graphs next. So yeah. So let's do one more sliding window. Let's try to get this going. Given two integer arrays, nums1, nums2, return the maximum length of a subarray that appears in both arrays. Nums1, nums2, 1, 2, 3, 3, 2, 1. Okay. Okay, they appear in both subarrays. Okay, so we gotta have like two sliding windows going on and kind of adjust based off if they are there. So if they differ, who do we move? Right? Should we move this one or this one? Interesting. This one, so we have an issue here. We want to get this going. Like, I don't know when to move either or, but okay. When should we move these, right? We have two lists here, so we compare, right? Right, we have two lists. One and three. Right, so we both have an L. Oh, I guess we have R. R moves. R moves again. We have R here. We have R. I guess we can keep going. Maybe we can have. You know, I had an idea. What if we combine the list, right? Would that change anything? Like, we start here and start this. pointer at the start of this list and the pointer at the start of this one, right? And I guess keep going. Yeah, we should have a stationary pointer at nums2, right? Until we find a match. Because if we exhausted every single option, then there's not going to be a subarray that exists, right? In both, right? Can this pointer stay stationary until we match it? Like, my idea was, like, okay, keep moving this until we find a match. The only problem with that though is that we might miss some subarrays because, like, let's say there is one like later on here. Like 214 could be in here. But we will never know. Well, yeah, we would. Yeah, that's the problem. I can't have this stationary. You know, alright, 3, 2, 1. Maximum length of a subarray that appears in both arrays. Like, we have this and this. I'm freaking trying to think of a solution of how to move these. But, I don't know. Okay. A rolling hash. That's a crazy one. DP. Do I need to sort this? I can't really sort that. Doesn't make sense because I have to. They need to be in the. It has to be subarray. Like, I was thinking like this stays stationary and then you move along all the way. We have some kind of solution. Okay, so we have L and R right here. Do we move forward? So we only move M2 when there is a subarray that meets. Are they the same length? Oh, they could be different lengths. Okay. They can be different lengths, so I have to consider that. Oh man. So I have to low-key try every scenario. I can't really think of anything else. So this will be one at a time. So we'll do this. So we'll have a j pointer, an I pointer, right? While j length of nums of 2 we'll do that, right? But every time, for every one, I want to compare. So for every I in range of length of nums of 1, nums of I and nums of j, if equal, then, right, we started something, right? So if they're equal, temp I is temp 1, temp 2, ij, I increment, or I guess temp increment, temp 2 increment, but, oh my god, this is like a triple pointer. So while I guess nums of we'll move that. Let's say they aren't anymore, then we'll do we could do res equals temp 1 minus I minus 1. This is gonna be not time efficient, but I can't think of any. Yeah, it's gonna suck. Yeah, this is for sure gonna suck. And temp 1 temp 2 2 Is this it? This probably is not gonna pass though, because I have like 3 for loops going on. So this is gonna be, how big is it? 1,000? Yeah, pretty slow. Let's see how we can optimize it. Let's try to think how I can optimize. What is the main issue? I think the main issue is I'm actually comparing too many there's too much going on. Is there a way to make this more efficient? Like detect if, yeah, I don't know. I don't know how a sliding window would work. Yeah, I literally got that. Got the brute force. Binary search. Binary search also does TLE. Binary search with rolling hash. Wait, where's sliding window? I want to know where sliding window is. Sliding window. Alright, let me see. By making one pass through the overlapping parts using 2 pointers and increment L by 1 if... what? Okay. Negative n plus 1 to n plus 1. Okay, I guess you're merging the two lists. This one doesn't look that intuitive. I think this is a pretty bad problem. Not a very good sliding window solution. I think this is a sign that I need to stop doing sliding window. So tomorrow we'll do some graph problems because I want to get practice on those. But anyways, thanks for watching. I'll see you tomorrow. Peace.